Welcome back to Studying Social Inequality with Data Science. If you're just joining us, this is part of a series, and you can look in the description down below to learn more about where this fits within our course. So today we're talking about filtering data. So this is the data wrangling cheat sheet from RStudio, and we can see the operation we're going to work on today is subsetting observations by rows. So visually, we can imagine having a data set with many rows, and in that data set, we want to filter here only to the blue rows. And so we have a test. Is this row blue or not? We're just going to keep that row if it's blue. And we'll end up with a data set that has fewer rows than the data set we started with. So here I have a directory on my computer where I have the data that I'm working with, and also the RMD file that has all the steps for this class exercise. And for this video, I've pulled out just the key components of the filter step so that we can focus on those today. So I'm going to go ahead and open this RMD file. Now, when I open the RMD file, you see that I've opened a new RStudio window. And several people have had trouble with their working directories. So I want to note that when you click an RMD to open it like that, and it opens up RStudio, it should put you automatically into the directory where the file is located. So here, if I make this big, I can type get wd and see that this directory is the same directory on my computer where the RMD file is located. Now, if you didn't get that, you can go up here to Tools, Global Options, and then you can see what your settings are for RStudio. If you go to R Markdown, it should say Evaluate Chunks in Directory Document. So if you got it on something else, then you want to come back to this default setting, which is Document, and then your working directory should be set as soon as you open that document. If you're having trouble, just Google how to fix your working directory, and you'll get some answers online. So in previous sessions, we talked about loading necessary packages, and we also talked about how to use the read DTA function from the Haven package to read a Stata data file, which has this suffix .dta. We also downloaded that DTA file from IPMS online. So if you want to learn about that, go back and look at those previous videos. So here today, we're going to talk about filtering. We want to create an object filtered, which has fewer rows than our original object, micro. To do that, we're going to create a new object filtered and store in that object the output of a call to the filter function. And over here I have the help file for filter open, which is always a good place to look when you need help. So the first argument to filter is the data set we begin with. So .data equals micro in this case. Then the next arguments are logical conditions, where we're only going to keep the rows for which those logical conditions are true. So our first logical condition is going to be to restrict to full year workers. In this case, that's coded in the documentation as weeks worked to equal to 6. And note here that when I'm passing an argument to a function, I use 1 equals sign. And when I'm testing a logical condition, I use 2 equals signs to test for equality. So if I run this line of code, I now get to a filtered object. And we can compare the number of rows in my micro object to the number of rows in my filtered object, and see that there are fewer rows in the filtered object than in the micro object, which is great because that's what we wanted to accomplish. And if we do summary micro dollars weeks work 2, we'll see there are many values. And if we do a summary on that same variable in the filtered data set, we'll see that they all have the value 6. So what we've done is taken micro and restricted only to the rows for which weeks work 2 equals 6. I want to introduce you to another way to do the filter operation, and that uses the pipe operator. The pipe operator is a key idea that we'll use repeatedly with tidyverse commands. So to do this by piping, I'm going to create an object that for now I'll call filtered piped to distinguish it from our original filtered object. When piping, we're going to start with the data set that we begin with. So micro is our big data frame. And then I'm going to use a special operator called the pipe operator. That operator is a % greater than %. Then I'll hit enter. And you see that RStudio has now indented the next line because RStudio knows that this is a special operator and that now we've piped from the first line down into the next line. So here we're going to pipe into the function filter. And inside that function, we'll put our logical condition. Weeks work 2 equal to 6. Okay, so what's going on? So micro here is a data frame. The pipe says to hand that data frame down to the first argument of the filter function. So here we skipped this argument, data equals micro, because filter knows that it's going to get that first argument from the pipe from above. And then after that, the command is just the same as before. So now we just have our line of code telling it what logical condition to be tested to keep a row in the data set. So why pipe? One reason is to make your code more readable. So this reads like a sentence. I begin with the micro data frame. Then I do something else, which is to filter to cases for which weeks work 2 equals 6. Second, piping makes it easy to comment your code. So here I can add a comment, subset to cases working full year. And this is great because I start with my micro data set, I have a comment telling me what's coming, and then a new line of code telling me what happens next. And we can see if I run this code that it results in the same object. So here we can use the all equal command to test that these two objects are equal. So this is going to ask is the filtered object the same thing as the filtered piped object? And when I run that command, it returns true because those are the same object. So we see here that piping achieves the same task as using filter without a pipe. In general, we're going to default to using the pipe because it's more readable and it makes it more easy to string together multiple commands. So I'm going to drop that non-piped version and just work with the pipe. So we aren't only restricting to those with this full year restriction. We also want to make a restriction on the income variable and these education codes. And piping makes that super easy. So in one line, we've restricted to full year workers. And now we're going to pipe that restricted data set down into a new filter command. So next we'll subset to cases with valid incomes. And that's going to be a call to filter, where we're going to filter on this requirement, where we determine this definition of valid incomes by looking at the survey documentation. And then finally we'll pipe it on again. So here we've taken micro, now we've restricted to full year workers, now we've restricted to those with valid incomes, and passed that restricted data set on into a new thing where we're going to run a line to subset to cases with valid education. And so here I'll use filter, and I'm going to put this logical condition in, where this condition is true if the case's education is greater than 1 and that case's education is less than 999. So I can run all that code together by hitting anywhere in this section and hitting command return. And now we can see that in our final data set, we now have 1,323,760 observations. So that's how to filter data. Next, we're going to talk about mutating data, and we'll get to that on Friday.